Hello, and welcome to another episode of Yummy Data Science. In this episode, and the next one, I'm going to be talking about readmissions. So, hospital readmissions. And the way I'm identifying readmissions or defining readmissions is saying that the person had an admission to the hospital for some reason, and then they were readmitted to the hospital, any hospital, in the subsequent 60, 90, whatever days time window that you're interested in. And it can be a readmission for the same reason or for a different reason. And we're going to be talking about predictive and prescriptive analytics. So why is it even important to have machine learning models to predict probability of readmission? Well, the whole reason is so we can prescribe some course of action and to take preventive action so that the predicted readmission, which is costly, does not take place. And what takes place is something else, an intervention on behalf of the patient that prevents this readmission at a much better outcome to the patient and at a lower cost. And as you know, hospitals have a clear incentive to do this, as do payers. So hospitals, Medicare has a policy that if it's a readmission for the same cause, it generally does not reimburse the readmission. So hospitals have a clear incentive to make sure that they are predicting readmissions and taking steps to ensure that they have as few of them as possible. And obviously, healthcare insurance payers have a same incentive because they want to minimize their cost and create better outcomes for their patients. So we can talk about these machine learning models happening at two stages. Stage two, I'll talk about that first. It's maybe the machine learning model is scored at the time of discharge. So you have a model, say you've created a perfect formula, and now it's being implemented, it's being put into production. And as each patient is discharged, out pops a score, and out pops up some recommendations for action. So this is something that the hospital can do. Maybe they can send a nurse out. Maybe they can call the patient. Maybe they can talk to the patient's caregivers. Or you could have continuous ML scoring as new data comes in. And this is something that payers are doing. Say, for example, there's an older person, he has been in the hospital and now he has gone home. And it turns out that he has recently picked up a prescription, a change in prescription for high blood pressure. And this prescription is going to make them more likely to be dizzy and perhaps have a fall. So that might be a trigger. There's continuous scoring going on. The new data came in, and then that triggered maybe a social worker or a nurse calling them, checking up on them, how they're doing with the medication, making sure that they have the support they need to provide a fall, to prevent a fall and prevent a costly readmission. So now what I'm going to talk about is instead of going directly to our data set, our synthetic inpatient data, and getting started on creating this algorithm, what I'd like to share with you is an approach that I've been using for quite a while, is that I like to write these things down. And anytime I take on data work, I like to write it down. What do I want to do? What is my data like? And I'll take a few simple cases of the data or edge cases. So, what I'd like to share with you is a Word document because this is how I've been doing it. You can do it in any other format, but it's the act of writing things down clearly that makes this a very worthwhile exercise. And it's kind of the philosophy what tailors use. You measure twice, cut once. So I'm doing all this preparation work. I am getting my thoughts, my logic, my goals in order. I'm writing it down. And then when I take it to code, then it will be very clear. So I'm writing a specification document. So here I'm saying that let's say my data is like this, what is given in rows 1 through 5, and I have two patient IDs, 1001 and 1002. And as you can see, record 2 is a readmission because it occurs 3 days after their last discharge. So this is 3 days after their discharge. So record 2 is a readmission. Therefore, a record 1 should be identified with this flag that this record led to a readmission. So I'm going to tag rows 1. I'm going to tag the readmit flag is going to be equal to 1 on rows 1, and on row 4, as you can see, should be tagged with the readmit flag of 1 because, as you can see, the next record after that, the admit date of May 21, is less than 90 days after the discharge date of April 28th. And the other rows, so 1 and 4 are going to be tagged with the readmit flag of 1, and the rest of the rows are going to be flagged with the readmit flag of 0. And the obvious one is number 3, because even though there is a record after that seems like a readmission, you'll see that the year is different. So the difference between these two is more than 90. So I've written it out and I have clarified in my own head what the requirements are. So in a way, I'm doing test-driven development. And what I'm doing is I've written down my test case, and anytime I write my code, it should give me the same result on this set of data. And nowadays, what I'm doing is instead of writing the program myself, I will now put this in an AI, get the solution, tweak it, and decide on the best one. And sometimes it takes me 4 or 5 iterations to figure it out, but it's certainly much faster than if I were to write it on my own. So the other interesting problem that I had with this data, and let me just add spaces here. So it's all on one page. So my synthetic data was not quite right. I was noticing that the admit date of a subsequent admission was actually the same day or even less than their previous discharge. So now I know that in order to do all this analysis and computation on the synthetic data, what I need to do is I need to quote unquote fix my input data. So I clarified this in my own head and I said add appropriate days to admit date and discharge date so that the admit date of the current admission occurs at least 1 day after the discharge date of the preceding admission for the same Bene ID. Like, look at this sentence. It's a mouthful, but it says in English exactly what I want to do. And then I'm following it up by saying, given the following data set, create Python code to add at least 1 day to the admit date and discharge date of row 2, 4, and 5. And then after appropriate dates are added, verify results to ensure admit date of the current admission occurs 1 day after. And so it's the verify that is important, because look then, and I'm just going to talk about it a little bit more, because, as data scientists, we don't think about programming in the same way that computer scientists do. And what this is doing for verification is using this assert statement. And the assert is a test-driven development a component in Python, and basically it will say, okay, if it fails this test, then it is going to stop the program. But if it passes, then it's fine. And then next, I'm going to show you how this all pans out and in Google Colab.